All right. Today we'll start with the muscular system. Okay. This is a very good drawing of the muscle. For skeletal muscles, okay, they are always inserted to the bone like this. So this is called an insertion point. Okay. And for the entire muscle, there are actually a lot of muscle fibers. These are muscle fibers. And this part is near the bone, near the insertion point, which is called tendon. Okay, tendon. And the outer surface of the tendon is called tendon sheath. Okay, it's like a thin cover. Tendon sheath. Okay. And the property of this part is different from the muscle of this part. Okay. The main part of the muscle, okay, looks like this. It consists of a lot of this kind of thing. Okay, this is a cross-sectional view of the muscle. Okay, and if you take a closer look, okay, looks like there's a lot of thing being bounded by something. Okay, again, these are very similar to a cover, a thin cover. Okay, and then if you look closer, it's covered by this something called fascicle. Okay, and then on this surface you can see this, I don't know whether you can see it or not. Okay, have I uploaded? Okay, so then you can use you can look at your computer or your phone or your pad. Okay, you can download this from Moodle. On the outer surface, there's something. It looks purple on my display, but the color may be different. Okay, and if you move this, okay, actually, if you cut it again, this is a cross-sectional view. You see exactly the same thing. This is very interesting. Okay, so this part, if I use another cursor, maybe better. Okay. A white cursor is not so clear, right? Can I change the color of the cursor? Probably not. This is always a white cursor. Can you see the cursor clearly? The mouse cursor? Because it's also white. White cursor on the white background. It's not. Okay. So this one particular fiber, this is called a muscle fiber. Okay, so within this fascicle there are a lot of muscle fibers, as you can see. So if you look at this muscle fiber, and it's here on the bottom right, this is one muscle fiber. And then if you take the cross-sectional view again, you see something also similar. Okay, you see this kind of separation. Okay, and then these are myofibrils. That means something even smaller than a fiber. Okay, and how big is this fiber? It's very small. Okay, but something can even get smaller, like this. These are called filaments. Filaments. And there are two types of filaments. Okay. One type of filament is called actin. The other type is called myosin. Okay. And this is one muscle fiber. As you can see, one muscle fiber consists of many myofibrils. Okay, and each myofibril consists of many filaments. Okay, and there are two types of filaments, actin plus myosin, and we'll talk about their function in a moment. Since this is a muscle fiber, actually a muscle fiber is a type of cell. Okay, and we know that a cell is consists of nucleus plus some other components. And muscle fiber is a very a different kind of cell. Usually in the human body we have a single nucleus cell, but muscle fiber is multi-nuclear. That means on each muscle fiber there can be several nuclei. So if you look at this muscle fiber, there are actually many. The green part, the nuclei. Okay, so on this muscle fiber there are many nucleus. Okay, so muscle fiber is not the kind of cell that we normally see or describe. Okay, usually we think that the cell is, consists of one nucleus. Okay. And then if you look at the top right, these are nerves. Okay. And there are also some vessels. Okay. So the nerve and vessels actually attached on the muscle fiber. Okay. And how does the muscle work? Okay. Something happened here. And when that something happens, the whole muscle fiber will work. And we call that contraction. Contraction. And if one muscle fiber contracts, of course, the other muscle fiber can also contract. And perhaps they contract simultaneously. Why? Perhaps they are controlled by one nerve. If this nerve coming from the brain, okay, and then give this muscle fiber, give these muscle fibers the same signal, trying to activate all these, then we'll have a contraction here. Every muscle fiber will contract. If you count the muscle fiber here, how many approximately? 1, 2, 3, 4, 5, 6. So, okay, so totally probably 20. And suppose there's a nerve attached to this fascicle. So all these 20 muscle fibers may do the same thing when they get the signal. Okay? And the muscle nerve, the same muscle nerve, can also probably, you can imagine, attached to this, right? It's possible. Because the nerve may have branches. If you look at this, the nerve have branches. So depending on how they are connected, some of the nerve, one nerve, control probably just 20 muscle fibers. Some other type of nerve, the branches, there are plenty of branches, and it's connected to many muscle fibers, maybe hundreds. In that case, okay, when the signal arrives, all of the muscle fibers will contract at the same time. So depending on the type of nerve, some of the nerve only activate a very small number of muscle fibers, okay, such as those in our eyes. Okay, our eyeball, we can turn when you look at different places. When you track objects, the eyeball is actually, not only your neck is moving, your eyeball is actually moving very quickly, like that. Okay, and there are a couple muscles doing this, and they are acting very quickly, actually much faster than your camera. Right? If you are shooting a bird, you think your camera locked the bird first, or your eyes. Your eyes actually much faster. Because those muscles are very small muscle. Only a couple muscle fibers are getting, controlled by one nerve. So as soon as they arrive, the signal arrive, they act, they control, they act. So they are fast responding muscles. Some other type of system. One nerve activates hundreds of muscle fibers, hundreds, like the ones in our arm, the ones in our thigh, in our leg, the ones in our back. Those are very large muscle, very big. So as you can imagine, when the signal arrives, hundreds of muscle fibers working together, of course, they produce very big force, very large power. But it's not going to be that accurate, that precise, that quick. Right? So, that's human factors, the ergonomics. Using your leg to sign your name. If I ask you to grasp a pen using your leg to sign your name, it takes a while to practice because you are using very large muscles. So the precise control is difficult. So if you want to do something very precise, very accurate, you need to use smaller muscles. And the eyeball is very accurate, very quick. However, it is very interesting. For the same person, the same brain, no matter you use your leg to sign your name, or you use your hand to sign your name, or you use your neck to sign your name, they look similar. Because it's a program. It has a program here. Right? The program is the same. The same program. You remember it. However, the control device is quite different. Using your leg, you are using a very heavy machine. Okay, the muscles are huge, big, with a lot of power, with a lot of strength, force. It's difficult to very precisely control when to turn, when to stop. But it looks similar. The pattern looks similar. So that's the difference. Okay? That's quite interesting phenomenon. Okay. The muscles here, these are muscle fibers. And there is no muscle fibers here at the tendon. Okay? In the tendon area, these tissues are very elastic. Elastic means something like a rubber band. You pull it, and the tension, the force increased. The longer you pull, the larger the tension, until at one time, at one instance, it break. Right? So it's elastic. So tendon is like that. You can pull it. The more you pull it, the longer it gets, and the larger the force it creates. With the muscle here, it's different. Okay, these muscles, the tissues, okay, it's not so elastic. You cannot pull it like a tendon, like a rubber band. If you pull it too much, you break the muscles. It happens. Many sports, athletes, okay, they get hurt. Sometimes they get hurt, they break the muscle fibers. Some of the muscle fibers actually broken, and it cannot recover. They are losing some muscle fibers. Okay, if many fibers are broken, okay, this entire muscle get weaker. Sometimes they get sprained. That means the tendon get hurt. The tendon being pulled beyond its limit. Okay? And here the muscle fibers can contract. When we say contract, that means, okay, we will talk about it, what is contraction. But that means it generates, it gives force. The force will be created here. So when the muscle contracts, it always creates a force in the direction toward the center. So the force goes like that. Okay? And as you can imagine, there may be another bone here attached. Here's another bone. Again, finally, there will be a tendon here attached. So toward this end, the muscle force goes like that. So when the muscle contracts, it's red. Maybe. Can you see that? So when the muscle contracts, the force always towards the center, pulling the bone, pulling the tendon here. Okay? So the tendon will be pulled. The tendon will be pulled by this force. And the tendon here will be pulled toward the center by this force. And that creates movement. Because the tendon connected to the bone, right? Inserted to the bone. So that's how the skeletal muscle works. So everything starts from contraction. And we will talk about contraction. How does that work here? Contraction is actually caused by something, some activity here. Okay? And then that activity creates force towards the center. So imagine something like this. If this end is loose, suppose this is your hand, okay, and then this is your, okay, somehow it's like a, suppose this is an elbow. Suppose this is an elbow, like that, and the hand is here, okay, and the elbow joint is here, okay. So when the muscle contracts, this angle actually getting closed, getting smaller, right? So it's like it's like that. It's getting smaller, right? When my muscle contracts, okay? And what's going to happen? As you can imagine, the length of this muscle will become shorter, right? Will become shorter. So any muscle connecting my forearm and my upper arm, like that, when you do this, when you contract, it's getting the angle, when we call this included angle, the elbow angle, will get smaller. And when they get smaller, that length, total length, will get shorter. Shorter. And that's one type of muscle contraction. You're actually moving, and the muscle length also change. The other case, another case, it is also possible that both ends are fixed. There's no movement while you are still giving force. So it's like this. There's no movement at all, but my muscles are still working. So it's possible that this guy is too heavy, I'm trying to pull it, but I cannot move it. So I'm exerting a lot of force, but there's no postural change, no movement. But my muscles are working very hard, trying to, okay, right? It's possible. This, I'm moving, trying to move. It is too heavy. So, in this case, it's everything. There is no movement, no posture change. So, while the muscles are working, are giving force, there is no change in its length. The length doesn't change, right? Because posture doesn't change. That's the second case. Static. We call that static condition. Static, everything static. Yet there's another case. Okay? When I push this guy, when I push, and this angle enlarge. That angle actually enlarge because I push and this guy moved. So when I push it, this angle gets large. So what's happening? You are also giving force, but the muscle length actually increase. Right? But remember, no matter what kind of conditions, what is the direction of the force? It's always toward the center, because muscle is always contracting to give force. But the muscle length can be elongated, can be getting longer, can get shorter. The muscle gets shorter, looks like the force is in the same direction as the muscle length change, the displacement, the length change, right? So in some cases, they are in the same along the same line, along the same direction. In some other case, it's in the opposite direction. Opposite direction. Okay. Now, let's take a look at what happened here. Okay? This is a cross-sectional view, but when we look at the side view, it's like this. This is the muscle. These are tendons. Tendons here. Muscle belly here. The muscle. And at both ends there are tendons. Okay, when we zoom in, it becomes this. When we zoom in again, now this is a single muscle fiber, which is a multinucleated cell. As we can see, a lot of nuclei here on the outer surface. When we zoom in again, each of this kind of very small fiber, which is called myofibril. Myofibril. And now we are looking at one single myofibril. It's interesting. We see something like this. Some of the area is darker. Some of the area is lighter. Some of them in between. If we zoom in again, it looks like this. Each from here, from this line, okay, this line, to this line, we zoom in again. And this line is called Z line. Z line. Okay, Z line. And this, from one Z line to the next, we call it one sarcomere. Sarcomere. And within this sarcomere, okay, you'll see this gray area, which is called H zone. H zone. Okay. And then the darker area, okay, is actually called A band. A band. Okay? And then the lighter area is called I band. I band. Okay. And if we zoom in again, it actually looks like this. The darker part is really because of there are two things overlapped, and it gets darker. The lighter I band is because there's only one thing here, and this one thing is called thin filament. Thin filament or actin, which is actually a certain kind of protein. So this actin, thin filament, is thinner. And then this is myosin. Myosin is thick, and it's also called thick filament. Actually, on the surface of this thick filament, there's also something. Okay? In the microscope, they look like some tiny balls, very tiny balls on the surface. Okay? So the overlapping makes it darker. Okay? And this is one sarcomere. Okay, and it looks like this. So now if you look at the muscle fiber or even the muscle, the entire muscle, you can see there's some, we call it striation. Okay, there are some lines like this, the vertical line. Okay, if the muscle fibers are horizontal, the striations are vertical on the surface, like this. Okay, this is why skeletal muscle are also called striated muscle. Okay, let me write it down. Striated muscle, they look perpendicular to the muscle fiber. Okay, I think we learn this kind of thing, not as much detail like now, but we learned the names long time ago. We know that skeletal muscles are also called striated muscle because of these striations. There's another name. Skeletal muscles are also called voluntary muscle. Right? Ever heard? I think we learned this long time ago when we were pretty young. Voluntary. Voluntary, hopefully I'm spelling correctly. Voluntary muscle. Why voluntary? Because they contract. Remember, the force always goes toward the center. They contract. C-O-N. They contract. When do they contract? When they get a signal from the brain. When you want to reach for something, when you want to grasp something, when you want to push something, when you are actually maintaining your posture, when you lean forward, you're doing this based on the signals from the brain. But through the nerve. And those nerves are called motor nerves. Motor nerves. Because they control the motor behavior. Motor nerves. You know, there are two types of nerves, right? Motor nerve getting signal from the brain going to the muscles. And then you see the motor behavior. Sensory nerve getting stimulus from the skin or some other receivers, getting information and then going to the brain. So when you touch something hot, you know it. You are sensing something. That's sensory nerve. So one is going up to the brain. The other one is going down to the motor. Okay, and in physiology, there are different names, alpha and beta. Different names for it. But basically, musculoskeletal muscles are also called voluntary because it's based on your will. Okay. The tendon here, there are tendon here. These are tendon and it's connected to the bone like that. These are tendon. The tendon, it cannot contract at all. There is no acting, no myosin there. It's passive, it's elastic. The muscle contracts voluntarily. The tendon will be pulled. Okay? Okay, so it's very interesting. Based on that structure, when you get some signal from the brain and this contract and then the tendon is pulled and then this bone is being moved. Now, how do we get the maximum force? Maximum force, of course, if all of the muscle fibers are being contracted, then you get the maximum force. That's one way to get the maximum force. If you do this slowly, okay? Compare, just imagine. Try to visualize by yourself. Compare to you do this very quickly. Sometimes we call this jerk, we jerk it. You know what is a jerk? If you are being called a jerk, it's no good, right? This guy is a jerk. That means his behavior, his pattern is unpredicted. Okay, so when I try to reach my bottle, I can do it smoothly, slowly, gracefully. If this is getting very heavy, like this, it's immovable. What would you do? If this is very heavy, what would you do? You would not do it gracefully, smoothly, slowly. You would do it. Try to jerk it. Why? Because you know, if you do it smoothly, you contract slowly, you're not going to get enough force. The force is not big enough. Because now the thing is too heavy. So, what would you do? You would do this very quickly so that this tendon is, remember, this is elastic. This is like a rubber band. So that this tendon can be pulled immediately, as quick as possible. As the tendon is being pulled, it creates a very large elastic force. So the total force is a combination of the tendon force plus the muscle force. Under that condition, you get the maximum pulling force. Then you are able to jerk something up. So when you are trying to lift something heavy, you will not do it slowly. You will do it very quickly. You jerk it, right? That's what we see. A lot of people are doing that. You are actually trying to use the tendon. If you do it very slowly, the tendon will not work. The tendon just transmit the force. Only when you jerk it, the pulling, the force here is produced very quickly. So that means this part is shortening, it's getting shorter very quickly. Then this is pulled. When this is pulled, it creates additional tension so that the total force is big. Okay. We haven't talked about the injury or some kind of problem. Would this create problems? Yes. So many industrial workers, they jerk their movement, but they don't know. Because they are required to do a lot of job very quickly, very fast, very heavy. So they have to jerk it. Because they are doing this repeatedly, you know that in the morning they are full of energy, they can do very good job. 2 hours later they are getting tired. In the afternoon the muscles are tired, fatigued. So strategically, they know how to take care of themselves. Because if you jerk it, you are actually reducing the muscle load. You are transferring the load to tendon. Similarly, if you are an athlete, in order to get the maximum performance, when you are trying to jump, when you are trying to play basketball, to jump very high, what you're doing? You're actually jerking your movement, and that can be harmful. So sometimes you sprain, your tendon gets sprained, get pulled too much. So they do get people injured by jerking it. But they also save some of the energy by doing that. So skillful workers, they know how to balance that until one day they get older or they get too tired, they got injured. Okay. Now, let's look at how the contraction works. Actually, the contraction, works this way. When something happens here, the actin and the myosin are attracted to each other. Okay? You can think of the myosin as the female. The actin is the boy, the male. So boy is here, girl is here. They are attracted to each other because of some of the chemical reaction here. There's indeed something chemical. And when this guy see this girl and they love each other, and then they attracted, and then they got closer to each other. When they got closer to each other, this sarcomere actually shortened, becomes shortened. That's what happened actually. There is some chemical reaction here. Because remember, this is within the cell. Within the cell. There are a lot of, chemicals here. Okay. This is the steps leading to the contraction of skeletal muscles. Okay. What time is it? Let's take a 10 minutes break.